Hello, everybody, and welcome to another episode of Recently in the Support. Today, I would like to show you how to build submodels in Abaqus CAE, because that is a very, very useful technique to model fine regions. Imagine you have a housing or something like that, a real huge model, which you would like to mesh with a coarse mesh, but you have local stresses in some local fillets that you would like to evaluate. So you need a really fine mesh in these areas. That is very difficult to mesh in the global mesh. So there is a possibility to cut out those regions which you would like to evaluate in more detail, and then calculate only those sections. Let's see how it works. So here we have a model with a flange which is bolted to a housing, and we have a shaft pressed inside this flange, so there's a press fit simulated. So that's a complete assembly model, which we meshed quite coarse in order not to have too much elements. But in this fillet area here, we might want to know more exactly what the stresses are, so we need a finer mesh there. Of course, it would be possible in this model to refine locally, but I want to show the possibility of submodeling. So what we do, we make a copy of the global model here. Just copy the model and rename it to, let's say, submodel. And in this submodel, we make some partitions. We already did that, so we just cut out the fillet area, as you might see, just to simulate this fillet area alone. And yeah, we will now mesh this fillet area. Only this area, only this cell will be meshed. The rest will not be meshed. So the rest will be ignored in the simulation. And let me just show you now the segment we're going to simulate. It has now some cut faces where we cut out the model. And those are the areas where we now have to map the displacement results from the global model to the submodel. And we will do that with the displacement boundary condition. So we go to the first step, make create, choose other, and type submodel. So that is the way how you can define this submodel. We now define the faces, the cut faces, where we would like to map the displacements from the global model, and that's it. I already prepared that, so I'm going to cancel this operation now and open it. So we're in the first step. We chose the red areas to map the displacement on. The global model will be the global flange part. So I will explain later what happens if we don't do that. And we choose the degrees of freedom 1, 2, 3, and step number 1. So we take the results from step number 1 and map it to this geometry. Now we go to the submodel step 2, and we are going to take the results from global model step 2 also. In the step 3, we do the same. We just change the global step number to 3. So that's quite easy. And now what we have to do in the submodel on the left tree, we have to select right mouse click on that one. I will show it you right next. Then we have the model attributes, and we are going to edit these attributes. And then you see in the submodel ribbon, there we have to tell Abaqus which is the global model where we get the results from. So this is the ODP of the global model with all displacements results ready. Then we can run the submodel, and yeah, you can run it from CAE as you know it with submit. And in the end, you have the results. You can visualize it, and you will see that we have a very local stress distribution, which is possible to simulate with the submodel, and we only calculated what we meshed. So that's the idea behind that. Only mesh the cell you want to calculate. And now I would like to show you what is happening if you do not specify a driving region as we did before. Here we have an example, 2 bars. One is bent upside, the other one is bent downwards. So what we have compression stress on the right part and a tension stress on the left part. I will show it with the max principle. You see only the left part has a tension stress. So we built a submodel only of this part, only of the notch here. If we do not define the driving region, the following will happen, because we have two parts, and Abaqus will find the next part also and will map also results from the part we don't want to simulate. You see it on those nodes. It's from the right part where some nodes mapped to the submodel, and that's what we don't want to have. So let's do it different. We are going to define a driving region again, as we did in the example before. So I'm going to CAE, to the model now, to avoid this. And there in CAE, we will define the submodel boundary conditions, as we did it before, as displacement definitions. And there we specify now tile 1 as the global model part which we want to have the results from. So only from the left part now the results will be taken, and you see we have a clean stress distribution and no issue anymore. So don't miss to define the driving region when you are defining a submodel. And that's what I wanted to show you today. So it's not difficult to use submodels, only take care about the driving region. And yeah, I think it's quite helpful. It helps you also. And see you next time. Goodbye.